Osmosis is the movement of solvent molecules through a semi-permeable membrane into a region of higher solute concentration in the direction that equalizes the solute concentrations on both of the sides. In biological systems, these membranes are sieves, and the size of the holes correspond to the size of a molecule of water. If we apply external pressure to reverse the natural flow of the solvent, we are talking about a process called reverse osmosis. The solute is retained on the pressurized sides of the membrane, and the solvent is allowed to pass through. With this method of filtration, we can remove about 85 to 99% of the impurities of the water. I made a small animation about the semi-permeable membrane. As you can see, the smaller particles fall through the holes and the bigger particles stay in the same place. After a time, the pores or the holes get clogged up, so we have to clear these filters. This is how a filter looks like. This cabinet houses the PLC, which controls the process. If we open it up with the key, we can see the different parts of it. This is the on-off switch. Next we have the display unit. It's an input and output device because it can display data or send data to the PLC. This is the controlling part, the CPU or central processing unit. It has its own power supply and it has a communication interface which communicates with the PC with the help of the industrial Avon router. This means that it collects data through this Ethernet cable. Next we have the input and output interface. These are marked with different signs. These can be identified with the user manual. This is the manual which is stored on the PC and it's in Slovak language. We can read out the data from the PLC with WinCC. WinCC is a program used for visualization. It communicates with the PLC and it can get addresses from the hardware configurations. The CPU, power supply, communication and I/O interface are the most important things to control the process. The rest of the hardware helps and makes sure the main parts can function properly. This is an inverter which is needed for the big pump or motor. For bigger motors, we need inverters which control the revs of the motor. It asks the PLC about the percentage at which the motor has to run and the rest of the things calculates itself. Below the inverter we find a cooling fan which helps with the cooling of the unit. We will power up the device so you can see it turned on. When the lights turn to green, the PLC will be ready. The light has to be continuous and the start lasts for a while. At this moment it's up and running, and if we take a look at the display it shows the values now. If we jump to the PC, it takes a little while until the visualization shows the values. Now we can start MATLAB. Below the cabinet with the PLC, we find the pipes, valves, pumps and filters. This is the reverse osmosis 2 filter. On the left we will find the reverse osmosis 1, and in the middle we can find the ultra and nanofiltration. We can use 3 different filtering methods. The only common valve in all of the 3 methods is the V1 valve, which can be opened in the visualization. Each of the filters requires different valves and pumps to be opened. For example, reverse osmosis 2 requires valves of V4, V5, V16 and V20. These valves are opened and closed manually. Here you can see the different valves. This is the process of termination, so we need to close the manual valves. When the handle closes 90 degrees with the pipe, the valve is closed. If the handle is parallel with the pipe, the valve is open. Closed, closed, and that one is open. This is the last one, open on this side. Now we need to close V5 and V4 on the rear of the device. Now that we closed all of the valves, the process can be turned off. It's important to leave the laboratory in the same shape we received it.